and welcome to an episode of My Two Cent. It's Runday. This run's gonna suck. I'm not dieting properly, and I'm already in pain. My body's already hurting. So, um, the title is Clock Calendar, Compass, Clock, and Calendar. Um, so I I re I re I have a product that I'm trying to design that I'm working on. It's called I call it the Michelson number line. All it basically is a ruler. Its basic units are, how do I explain it? So its standard unit. If it was compared to a ruler, it's inch. Its standard unit is 4 centimeters. So the entire number line is about 15 centimeters long, because it's meant to be an applied device. It's a measuring device for building and construction. It's something that you can use as a scientist, as an engineer, as an artist. It's supposed to be an actual tool. So um, roughly 15. It'll be 15 units. Each unit is 4 centimeters. And what makes it difficult to explain is that the unit of 4 centimeters is subdivided into 10 units. So each unit is roughly going to be zero point zero 0.04 centimeters. And that's what makes it kind of hard to explain in that regard. But instead of an inch is divided into quarters. Like there's 12 units in an inch. For the Michelson standard, that standard 4 centimeters is divided not into 4 centimeters, but into 10 units of zero point zero 0.04 centimeters. So that's what you use to measure, and then you have 15 of those, and they range from 0, 1 to 15. The other side of the other side of the ruler will be 0 to negative 15. The individual units between 0 and 1 is point 1, point 2, point 3, point 4. 0.1, 0.2, 0.3, 0.4, 0.9, all the way up to 1. And then 1.1 up to 1.9, and then 2. So it shows you that nested relationship that numbers have when it comes to base 10 math. The main reason why it's hard to explain, and I'm going to get into this later, is we use 10 digits for our counting system, but it's the base, right? So binary is a base 2. I think its trinary is base 3. Hexadecimal is a base 7. Octal is base 8. The best example of octal scale are music and the chemical elements. Even though the chemical elements aren't stated as using an octal scale, they are kind of arranged around an octal scale. The color spectrum in the computer is a hexadecimal scale. It's based on the number 7. And it doesn't even use numerical sevens. It uses numbers in letters to represent its values, but it uses a system of 7 to describe all of the colors that we use. That's it. We use base 10, which is what all of our ones, tens, hundreds. And what a base number system is that number raised to itself for that unit. So in base 10, we're used to ones, tens, hundreds, thousands, 10,000, 100,000, millions. So 1 is 1, 10 is 1 raised to the power of 10, 100 is 1 raised to the power of 10 raised to the power of 10. So 10 times 10 is 100. And then 10 times 10 times 10 is 1,000. And then 10 times 10 times 10 times 10 is 10,000. So it's raised to that power. So if you wanted to calculate base 3 or base 4, you would do the same thing. You would raise the number to itself. So in base 3, the first unit would be 3. The second unit will be raised to the power of itself. So 3 raised to the power of 3 will be 9. And then you would just continue on like that. And that's why it's kind of convoluted and confusing, because we're used to the characters that we use in math for base 10, and then when we try to translate those numbers over to any other base, they lose their value. So 2 starts to you represent 31 with the number 2, and you're like, I don't understand how that works, but it's an actual equation that you would have to actually calculate. When I unified the number line, I also wanted to create my own protractor. So I sat at the computer and I built the protractor in Blender, not really knowing exactly what it was I was doing or why I was doing it. But I took the ruler and I made it a circle, and then the numbers went around a circle, and it was like 0 to 9.9. And I was like, that's interesting. At first I used 20 because of the clock. So there's 24 hours in a day. So since there's 24 hours in a day, I went 1 to 10, and then the other half was 11 to 20. And I looked at it and I said, well, why does it have to be 20? Why can't it just be 10? So then I made it 10, and then I was like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I was like, why does it have to be 10? Why can't it just be 0? Right? So because 0 and 10 are are relative to each other. So it was 0 all the way around to 9, and then it stops at 9.9, and then it restarts over at 0. Because 0 represents 10. You can just imagine that there's a 1 in front of the 0, and now you have 10. But if you start at 0 degrees, like the compass starts at 0 degrees, so I might as well just make it 10. So when I made the compass 10, I was like, well, what is the right angle? If I start with 0, then what is the right angle? And then from 0 to 2.5 gives you your first right angle. I was like, well, if 2.5 is the right angle, then how many degrees is a square? And a square is 10 degrees. It has 4 right angles of 2.5. So now a square is equal to 10 degrees. A triangle is equal to 5 degrees, because it has 2.5 it's 5. Wait. How a straight line is from 0 to 5 is a straight line, and then a triangle is, I'll have to look at it, but it all works itself out. Yeah, because of a right angle is 2.5 degrees, and okay, a triangle is, okay, I get it. A right angle of a triangle, because in my head I'm looking at all 3 types of triangles: the acute, the right triangle, and the obtuse triangle, right? A triangle by definition has angles that equal 180 degrees. So if you look at a right triangle is a right angle is 90 degrees. The 2 angles are 45 degrees, right? So in my system, the right angles are half of 2.5. So those 2 angles together equals 2.5, and then the right angle becomes 2.5. 2.5 plus 2.5 gives you 0.5. But it's in that relationship where when you're doing math for my system that you're not going to get an exactly precise division of 2.5. That is probably why we decided to just use 360 degrees. But 360 degrees is not as intuitive as 2.5 degrees, even if you have to round up or round down. We do it all the time anyway. So the next logical leap from that was, there's 12 months in a year because there's 12 hours on the calendar. Well, what if I made the day 20 hours? I could just make the day 20 hours, and then we can have, we already have a 24-hour day. I could just make it 20 hours to make it even. So when you take those numbers when you take the 24 hours and the 12 hours and you convert them down into the 20-hour day, and then you're like, well, if the compass has 10 hours in it, why can't I just turn the compass into, if the compass has 10 units, why can't I just turn a day into a 10-hour day? Why does it have to have a 10-hour morning cycle and a 10-hour afternoon cycle? The circle is the circle. The hand's going to go around the circle once. So why can't it represent what it is? So So now the day cycle has 10 hours. And if the day cycle has 10 hours, why does the calendar have to be convoluted? Why can't the calendar just be 10 units to represent the whole days? And the thing that I found most profound was there's 365 days in a year. And this is a relationship of taking the number of hour days and the number of rotations, right? So the Earth rotates 365 times, and one the Earth spins 365 times when it orbits around the sun once, right? So that's the relationship. There's no like numbers that need to be understood. The Earth rotates at a particular rate or cycle, and it moves around the circumference of its orbit around the sun so many times that rotation, right? If you take the orbital path of the Earth going around the sun and assign it degrees of 10, and you take the rotations of the Earth and assign them degrees of 10, you can make both of them 100, and you can find a relationship between the two of them, which gives you the Mitusin calendar. The Mitusin calendar recognizes that there are exactly 100 days, 100 degrees of movement around the sun that directly correlate to the 100 degrees of rotation of the Earth around the sun. What gets interesting is what I had to do to unify it was there's 10 months in a year, and there's that 0.5 days. There's 365 days plus the leap year. That's the conflict. And then we'll get into how that can be eliminated next. The 10 months relate to the degrees of the orbital path, right? So every even day, there's 5 even months and there's 5 odd months. So every even month, there's exactly 36 days, right? Every odd month, there's exactly 37 days. Since there's 5 odd months, you get an additional 5 days. So you take the 36 even days, right? That's half of the 365. You take the 37 odd days. Within that is the 360. So 360 times 10 gives you, 36 times 10 gives you 360 months, right? Every month has 336 days. Every month has 36 days. That's 360 days out of the year. There's a remainder of 5 days that has to be accounted for inside of the inside of the calendar. So every odd month inherits an additional day. So now every last month has 37 days. That's why you see the numbers, the videos for Rundays are like month 1, day this, month 2, day that. They all reset 36, 37, 36, 37, all the way down the year. I started the Mitusin calendar this year because this is the leap year. Every 4 years, based on our calendar, there's a leap year. This month is the leap year. So at the beginning of every leap year in my calendar, there's a day 0, right? The day 0 is the 367 days. So we just add it at the beginning of the year. So month 1 has a day 0, and it still has 37 days. So month 1 has an even number of days, which is 38 days, and then that gives you that alignment. Now, we measure our rotation of the Earth around the sun, and we measure the spin of the Earth in relation to the rotation of the Earth around the sun, and we can't quite get it exactly the way we want it, because we want to be able to use our working daylight hours and our productive daylight hours and our unproductive nighttime hours. And as we have evolved and have developed better tools for measurements, we don't really have we didn't have the necessary accuracy to be able to measure concisely, right? So we are actually in a condition now to where we can eliminate the need for a fixed leap year. We can either completely eliminate the leap year, or we can make a leap year however we want to make one. And what I basically mean is we can perfectly align using satellite and GPS and the actual location of the Earth in its orbital path around the sun, to where you don't even need to have where there's no need to actually have a 36 or a 37-day month. We can actually have a month that has whatever value. Well, we kind of are confined within that structure, but we can accurately measure the unit. We can actually accurately measure the planet's orbit so that we don't need day cycles and night cycles that exactly equal. I'm sorry. We can basically what I'm trying to say is we can actually calculate down the actual days so that we can eliminate leap years. And what will happen? What will be the most fascinating thing about this is if our clocks tick based on the actual rotation of the planet and the movement of the Earth around the sun, we would actually experience the most accurate time dilation of the Earth's movement through space, because we can calculate exactly where the Earth's location is and exactly what the Earth's movement is, and we can change our clocks in relation to that. We can calibrate our clocks not to quartz crystals, but to the actual movement of the Earth around the sun. And if you were actually watching the clock carefully, you would see the actual dilation of the time, because it would update real time. Just like I'm going live, our clocks can actually update real time in relation to what's going on. And because our systems are all computerized and programmed and interconnected, we could actually truly experience our actual natural flow of time, and we could actually do things within the actual natural flow of time. And that's what the Mitosin system actually is supposed to be about. And it will be a really cool thing to be able to see, because we, like Terrence Howard said, we do everything as an average. It's actually possible that the rate of time flowing on the earth does vary. That the reason why some days feel like they're faster and some days feel like they're slower is because the rotation of the earth isn't a constant. We give it this value of 24 hours a day, but there's nothing to say that it doesn't actually rotate faster or slower on any given day of the month or the year, based on other elements of its path through space and through time. We know for a fact that for it to go around the sun in a circle, that it has to slow down and stop and reverse its path. So knowing that its path isn't exactly consistent, it's not exactly concise. So it will be actually really, really cool to actually calibrate the day cycle with the actual rotation of the earth, and not just say that this constant steady rate that we've assigned and associated to the earth is the value that we use to say this is how long a day is. Imagine your day actually being as long as your actual day is. That's the most convoluted thing I can say without. I mean, I've been structuring this for a few years now, but how do you tell somebody that you made your own calendar and your own clock and your own ruler without actually coming off as a conspiracy nut and an idiot, if you want to actually approach it in a way that is objectively sound? Because it's easy for people to argue with you, or to tell you that you're not right, or to tell you, or for them to internalize this feeling of superiority and I'm absolutely right and he's absolutely wrong. It's easy to do that. It's hard to actually take a half a second to hear what someone is saying and make an effort to try to understand what is being communicated. Like when I went, the best example I could give is when I went to get my car worked on yesterday, and the boss, the guy that has the more authority, he said, pull your car in behind the Cadillac. There was three bay doors. He was like, pull your car in behind the Cadillac. So I pulled my car up behind the Cadillac. While I was doing that, one of the guys that worked there was doing other stuff. So when he seen me pull up behind the Cadillac and park, he like, pull over here in the empty bay, right? So logically, I should pull over into the empty bay. But his boss told me to do something different, right? So instead of listening to the guy that doesn't have more authority than the other guy, because I get irritated with that at work when I'm working, right? My crew is constantly telling me how to do my job. I got confirmation from his boss that that's where he wanted me. You wanted me to pull up, sir, you wanted me to pull up behind the Cadillac, right? He's like, yeah. And then the other guy's like, oh, okay, well, whatever. Because we don't know everything. We don't have all the answers for everything that's going on in the world. We don't have all the information because we're not omnipotent, all-knowing gods. So it's a simple ability to communicate and understand. I wasn't disrespecting him by doing what his boss told me to do. You don't have all the information, so you should be able to listen to what I'm saying. If you don't want to listen to what I'm saying, because I'm like, I think he wants me to park here. He's like, no, 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 you can just park here. It's like, but yeah, but I think the other guy wants me to park here. No, 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 you can just, because he's ignoring me. Like, you don't have, well, how are you going to tell me something, right? So, that's the foundation of my 2 cents. Coming up with a universal capacity by which we can communicate so that we can be functional. That's it. There's nothing else that needs to matter beyond that. Like, as long as we're able to do that at our level as humanity, then we are actually slightly above the animal. Because the animals communicate pretty well at their own level. They can't come together and fight off a tornado or something, or conquer a flood, but their ability to interact at their own level within themselves is inherently superior to ours, because we can't even do basic stuff. Like, you can't even get food. Like, why is 9/10 of the planet? How do we live on a planet where we're producing more food than anyone? We throw away so much food collectively, right? Yet we still have people starving. Like, it was one thing when there was famine on Earth because there wasn't enough productivity. Why is there still famine on Earth when there is enough productivity? Like, how do you not solve that problem, right? Like, we addressed the issue where there wasn't enough food, but now we have to address the logistics of getting all of the food to where it needs to be. The only way we could do that is to come to a universal understanding and a common discourse. That's ultimately the foundation of my 2 cents. I'm ranting and raving. It's time for me to do this run. It's gonna suck. I'm gonna hurt. I'm already hurting because I didn't eat right. So let's just make this happen.
Lap 1. Lap pace 10 minutes 31 seconds. 1 mile. Heart rate 150. Lap 2. Lap pace 10 minutes 53 seconds. Total 21 minutes 15 seconds. 2 miles. Heart rate 154.